Hello everyone. So in this video, I will talk about the types of wave as well as some numerical problems of sound and wave. Um, so first start from these types of wave. So depending upon vibration of medium particles, we can divide waves into two types. The first one is longitudinal wave and the second one is transverse wave. So as you know, when wave travels in medium, the medium molecules will vibrate, atoms will vibrate, but they will not, there is no resultant translational motion. So it means the particles are vibrating from their mean position, which is called equilibrium position. When they are at rest, they are at equilibrium position, mean position, and when they start to vibrate, they will start to vibrate from their mean position. So they will hand their energy to the next molecules. That's why the wave carries energy. So in first case, the wave is traveling from left to right. So it is moving from left to right. So the molecules are vibrating along the direction of motion of wave. So this is called longitudinal wave. So they are vibrating, the molecules inside a medium are also vibrating along the direction of motion. So during this vibration, it will form a different region in this medium. So one is molecules are comes closer. You can see this region, these three region, they are come closer, but there are some region where molecules are far apart. This region, when they are come closer, and this in that region the medium is more denser, which is called compression. They are compressed. And the other region, when they are less denser, going apart, the molecules are going apart, that is called rarefaction. So in this case, this is compression, this is rarefaction, compression, rarefaction, and compression. You do see compression and rarefaction, they actually occur alternatively. So next one is transverse wave. In this case also, the wave is moving from left to right. So it is moving with velocity from left to right. But the molecules in the medium are vibrating perpendicular to it. So it's going up and down, okay? Up and down. So the dotted line in the middle, which is a mean position, when there is no vibration, all molecules are rest at that point. But when it start to vibrate, it start from up and down from its mean position. So it will go maximum up direction. So what is maximum displacement in either direction? It's called amplitude. Maybe up or down. One side you can take positive, other side you can take negative, but the magnitude is same, which is called amplitude. And its displacement from mean position varies from amplitude maximum value to 0, and all the way other side is negative a. So the maximum displacement in upside is called crest. This is crest. And the maximum displacement on the bottom side is called trough. Okay, maximum displacement on the bottom side is called trough. So as you see, there is crest, trough, crest, trough, and crest. So crest and trough will alternatively arrange in wave transmission. So the distance from one crest to another nearest crest, or one trough to other nearest trough, next nearest trough, it's called wavelength, which is denoted by lambda. In longitudinal wave, the distance from one compression to another nearest compression is wavelength, or one rarefaction to other next nearest rarefaction is called wavelength. So this is about this wave and type of wave. So I want to go to the problem. In problem, here is a wave. For simplicity, I use transverse wave. So I want to calculate, I want to know, I just want to know what is the velocity direction of a particles in this picture. So I want to assign point A, okay? Other point you can assign point B. Next one is point C. The other one is point D, and I can assign anywhere is point E, okay? So I want to know what is a particle velocity direction at every point. So wave is moving along x direction from left to right, positive x direction, but particles are vibrating up and down. So sometimes it goes up, sometimes it goes down. So they do have different directions. So I want to know. So the first one is start from A point. This point A is maximum displacement of direction. So at that point, it changes the direction. So to change this direction is momentarily at rest. So at point A, it is at rest. So it means momentarily rest means it has zero velocity. So zero velocity means no direction. You can think about this. This one is example of this. If you are throwing something in some stone in vertically up, then it goes up and maximum height, it changes direction. It will come down, yes. But between this time going up and down, there is momentarily at rest. The stone is at rest at maximum height. So in vertical motion, you usually take velocity of an object while moving vertically up and down. The maximum height velocity is zero. Same thing over here. Now go back and look at point B. So at point B, it's mean position, yes. But if you look at immediately after this point B, it is going down, yes. So at that point, the velocity should be downward direction because it's start to going down. So point C is exactly as a point A because it's maximum displacement in downward side. So at that point, it start to change its direction. So it's momentarily at rest. So its velocity is zero at point C. Zero, no velocity means no direction. At point D, so if you look at immediately after point D, then it's going up. So at that point, the velocity should be going up. And point E, if you look at any point in midpoint, so if you look at immediately after midpoint E, then it is going down. Yes, so the velocity should be down. So I want to just look at and show you how this transverse and longitudinal wave will go up and down. So look at here, I'm sharing some wave side over here and want to show you some wave motion. Look at here, this is real-time motion. So the particles over there is the pink color, it's moving up and down, and the green color, which is wave, it is moving from left to right. So if I change into longitudinal wave, this is transverse wave. Look at here, the particles in the medium are vibrating, and sometimes they are coming closer, which is compression, and some region they are going apart, which is rarefaction. So this is about compression and rarefaction, okay, and wave. So I want to go back and do some problems again more. Yes. So to do the problems, so you want to always make sure you are doing right thing. So I do have general strategy for this problem solving. So first number is you make a sketch of problem, if any. Sometimes it is easier to identify the problem and write down all the values, and if you make a sketch. Sometimes you may not, all the given values are given, so you don't need, but problem one is, the option one is, number one is optional, depending upon the problem. Second point is write down the given values with symbols. So you have to write all the values, even they are given, you want to write over there with their units. This will summarize what is given, because while doing problem, you have to look at what system of unit you are calculating. So if you mix up with the centimeter, meter, kilometer, then your calculation might be wrong later. Okay. So it means if you write everything with their corresponding units, you already know which systems I'm using. And if they are mixing of unit, you're going to convert from one system to another system. So that is second one. Third one is write down what you have to calculate, which will identify what is question is asking. Yes. So after knowing, if you clearly write 2 and 3, then you're going to choose appropriate equation, which you have to calculate, which is given. Find out from equation sheet which equation is appropriate, or which principle you want to use to calculate. Sometimes you want to use just principle, sometimes you want to use some concept, sometimes you want to use some equation to calculate, and plug the values which is given and solve for it, solve for unknown value. And finally, you have to write the answer again with appropriate unit. Don't forget to write the unit, because as I discussed earlier, if you have like, if you write some length as 1, it doesn't make any sense. 1 means what? 1 kilometer, 1 meter, 1 centimeter. So 1 centimeter and 1 kilometer is that completely different values. So you have to make sure the answer, what is its unit you are using in calculation, and what should be its unit in final answer, you have to mention over there. Okay, let's go back and look at one problem. Here is given one problem, so which is graphical problem. So wave is moving from left to right. So in this problem, the wave is going, it is given, wave is going from left to right, which is given. And next thing is given is the velocity of this wave traveling is given 5 meters per second. So wave is going from left to right, going along the positive x-axis, and velocity is 5 meters per second. Now, what you have to calculate is, you have to calculate what is its amplitude, what is its time period. Time period is denoted by this uppercase T, and what is its frequency, and what is its wavelength. Wavelength is denoted by Greek letter lambda. These are the things you have to calculate. Now, look at here in this example. So the y-axis is given in meter, which is wave vibrating in vertically up and down. Wave is propagating along the x direction. So this is transverse wave. So it is, you can see over there. So distance from this mean position to maximum point is 4. So which is given in meters. So you can look at it over there. And same thing over there. The distance from the particle vibration from its mean position to vertically down is also -4 meters. So the maximum displacement either direction is amplitude. So if you want to solve this A, then amplitude is equal to plus minus 4 meters. So if you want to write this magnitude, that is 4 meters. Yes, amplitude is 4 meters. So it means it's vibrating maximum value of 4 meters either direction of its mean position. So that is indicating. So B, you have to calculate time period. Look at the graph. So it is plotting in terms of displacement of particle with respect to time. So the time is in x-axis. So if I look at here, start from 0. So this is 4. So I can divide into different parts. So this is 1, and this is 2 seconds. This is 3 seconds. That is 4 seconds. Yes. So in between this point is 1.5 second, 1 second, and this is this is 0.5 second and 1 second. This is 1.5 second, 2 second, and then this one is 2.5 second, 3 second, and later is like 3.5 second. I can split into different parts. Okay, so time period is the time it takes to complete one revolution, one rotation, one oscillation. I just want to give you one example of this simple pendulum at first to go and calculate this one. Okay. So if you have pendulum hanging like that, stationary, its mean position, you want to slightly move it to one side, okay, and then release it. So what will happen? So if you move it slightly in from its mean position, which is point O to point A, then if you release it, it will go from mean position and to the other side. Let's say this is point B and come back to the same point A. So if you release from A, it goes other side B and come back to the point A. So how much time it takes to complete one complete oscillation going from A to B to come back to A? That is time period. So it means in this way, so if you start from the crest, so it goes other side and then come back to the same point, the crest. Okay. So I'll write this point, crest point A, and other point crest is B. So time to take from point A to point B is one time period. Or other way you can think, you can start from the struck to trough, which is also same. So in this case, the time period is going from A to B. That means B is 2.5 second. Yes. And A point is 0.5 second. If you subtract them, you will get 2 seconds. So going from A to B is 2 seconds. That is time. Now, number C, you have to calculate frequency. The frequency and time period are inversely related. So frequency is inverse of time period, or time period is inverse of frequency. So if you switch this value, you already calculate time period is 2 seconds. So you will get 0.5. So that is 0.5 hertz. Unit of frequency is hertz, Hg, or inverse second, whatever you write. Now, point D, you have to calculate wavelength. So to calculate wavelength, you have equation related to velocity, frequency, and wavelength. That is V is equal to lambda times F. Okay. Frequency is, velocity is equal to wavelength times frequency. So switch the values what is given. So velocity is given 5 is equal to lambda, you have to calculate, and frequency you calculated right now is 0.5. Yes. So divide both sides by 0.5. What you get is 0.5, 0.5 will cancel. Then you will get lambda is equal to 5 divided by 0.5. Now solve this, you'll get 10. So I'm using SI system of unit because velocity is measuring right now is meter per second and time is in second. So lambda is distance travel in complete one complete oscillation, one complete vibration, or one revolution, or one complete vibration. That should be in meter. So this is second problem. Let's go back and look at a little bit difficult problem for this one. Okay. Now a boat. So a boat rider is boating on a lake. So due to the water wave, maybe due to wind or whatever it is, so start to move it up and down. You might say really, yes. So it's moving up and down. If you see in the picture, it's moving up and down due to the water wave. Now, the spacing between wave crest is 20 meters. So you already know wave spacing between two crests, or wave spacing between two troughs is wavelength, which is given 20 meters. Now the speed of wave, which is traveling with 5 meters per second. Yes, that is given. Now you have to calculate how long does it take the boat to go from top of the crest to the bottom of the trough. So going from top of the crest to bottom of the crest. Yes, in this example is given over there. So top of the crest to bottom of the crest. So that's one. Now, as you remember, as I discussed earlier, so we have to calculate time. Yes, time, which you have to calculate. Yes. Now, look at the concept. So I already told you what is time period. I'm talking about the time period, not time. Time period is If you start from the crest and go back to trough and come back again crest, that is time period. Yes, going from crest to trough and come back to again crest, whole period is time period. But here we have to calculate just going from crest to trough, which is half of that. Yes, so it means we have to calculate time. That is from our concept. I already know that should be half of the time period. Now, then you want to calculate time period at first, and you can easily calculate time. So to calculate time, you need frequency, because frequency is time are inversely related. So I can use this V is equal to lambda times F to calculate frequency at first. And then from there, I can calculate time period, and then I can calculate time. So I want to directly substitute this value. So P is equal to lambda, F is 1 divided by T. Yes, because you already know F is inverse of time period. So write down all these values. So G is given 5 meter per second is equal to lambda is given 20 divided by time T. You need to cross multiplication, you will get 5T is equal to 20. So I'm going to divide both sides by 5. How much do you get? T is equal to 4 seconds. Yes, 4 seconds. Now you have to calculate time to go from crest to trough, which is half of the time period, which I already described. So that means 4 divided by 2 is 2 seconds. So to go from crest to again come back to crest is 4 seconds, but to go from crest to trough is 2 seconds. On other way, you can calculate also going from trough to crest in this situation is also same 2 seconds. Now another type of problem, so which you have to calculate from wave equation. You're going to calculate different quantities. So in this problem, equation is given y is equal to 15 centimeter times cosine of some angle, which is given pi divided by 5.0 centimeter times x minus pi divided by 12 second times t. Yes, this is given. So in this case, look at here, length is measured in centimeter and time is second. So this is a system of unit. Whatever you calculate, always put in centimeter, kg, and second. Now this is equation which is given. The wave which is propagating is represented by this equation. But we do have a standard equation as you discussed in class. So y is equal to a times cosine 2 pi divided by lambda times x minus 2 pi divided by uppercase T times T. This is a standard equation of wave which is propagating along x direction. So in this case, uppercase A is amplitude, lambda is wavelength, and uppercase T is time period. Now in this case, what you have to calculate? So you have to calculate what is amplitude in our equation, B, what is wavelength, okay, what is time period, and what is the speed of this wave. You have to calculate this 4 thing. So let's go one by one. Problem number A. Okay. So equation 1 is given, equation 2 is standard equation. You want to compare side by side. Okay. So instead of A, there is given 15 centimeter in our equation. So directly comparing these two equations, you can get A is equal to 15 centimeters. So amplitude, magnitude of amplitude is 15 centimeters. So it oscillates from its main position, positive 15 centimeter up and negative 15 centimeter down. So it's vibrate 15 centimeter up and down, which is maximum displacement. Now, second one, we have to calculate wavelength. Now, if you equate these two equations, look at here, this 2 pi divided by lambda in this standard equation is corresponding to the given value of this pi divided by 5 centimeters. So it means I can write 2 pi divided by comparing this equation is equal to pi divided by 5.0, and that is in centimeter. So if I solve this, do cross multiplication, pi times lambda is equal to 2 pi times 5.0 centimeter. Okay, so divide both sides by this pi, then what do you get? Cancel this pi. I do get lambda, which is wavelength, is equal to 10 centimeter. So this is a wavelength by comparing this equation. So point C, you have to calculate what is a time period. Now look at here, time period is in second term of this angle of cosine theta. So I can relate this one, compare this one along with this values which is given in this second term of this cosine angle. Okay, so it means 2 pi divided by t should be equal to pi divided by 12, that is given in second in standard equation. So I can cross multiply, I'll get pi times t is equal to 12 times 2 pi. Yeah, that is in second. So I can divide both sides by, if you divide by both sides by this pi, and pi will cancel, you will get t is equal to 24. That is in second. This is C. Now in D, you have to calculate what is a wave speed of wave. So you have equation V is equal to lambda times F. So I already calculate lambda, which is known. I don't have frequency, so I can relate this lambda in terms of time, frequency in terms of time period. That is, frequency is equal to inverse of time period, 1 divided by t. So switch all these values. I calculated lambda is 10 and time period is 1 divided by 24. Okay, and then you can use a calculator to calculate this value. That is 10 divided by 24. You can convert into decimal place also, and that should be in centimeter per second. Just make sure, because lambda is we are measuring in centimeter and time is measured in second in our mathematical in our calculations. So it should be centimeter per second. You can convert into meter per second also, and you can convert into um, into decimal place also.